Question 18. AOD is the diameter of a circle, so that's this. Center O and radius 9. ABC is an arc of the circle. AC is the chord that is either side of that arc. We're given an angle here is 35 degrees. Calculate the area of that shaded segment. Well, the area of that shaded segment, as I see it, is the area of the arc. So that's this here. Subtract the area of the following triangle, this here. So we're looking to try and find the area of the sector, and we're trying to find the area of the triangle and then take them away from each other. Before we can do either of those, we're going to need more information about not only this triangle but this sector. We need an angle, specifically this angle here, and that's where 35 comes in. Now there's two ways that we can go about getting this angle. One of them is, this is the more difficult one to spot, your circle theorem starting from these 2 points here. The angle at the center, which is that, is equal to twice the angle at the circumference. So technically I can just double 35 to get 70, and voila, we have that. What most people would do, I imagine, so I'll show it as well, is would note that these here are two lengths of an isosceles triangle, because you've got a triangle that has two radii in it. From that, we then get the angle here as being 35, the base angles in the isosceles triangle. Add them together to get 70, take it away from 180, and that will give you this here. And then take that back away from 180, and we're left with 70 there because angles in a straight line. Either way, you get 70 degrees. Now we're ready to actually do stuff with area. Area of a sector is equal to the angle of the sector itself, which in this case is 70 out of 360. Basically tells you what fraction of the circle you're dealing with, times the area of the whole circle, so times pi r squared, which in this case would be pi times 9 squared. So it's 70/360ths of the whole area of the circle will be this bit there. Calculate does the rest after that and will give us this answer before you press the SD button. Because we've got more to do, I'm actually going to leave it in that form. I don't want the nasty decimal that's awaiting when I press the SD button, so I'm just going to leave it like that. For the triangle, we have our angle of 70 and we have 9 and 9 either side, so we can use our area formula from trigonometry. So the area of the triangle will be half AB sine C. Little a and little b in this case are our two sides 9, and sine C, sine of 70, is the angle in between. We type that into the calculator, and this is added reason why I didn't want to make this a nasty decimal. It's because when we type this in, it's not going to be a nice answer. The area of the triangle will be 38.057 blah blah blah, and then I want to use the answer button for this in the next calculation I'm going to do, because we're going to do the area of the sector, which I'm going to type in as 63 over 4 pi in the calculator. Then I'm going to subtract the answer button. But of course, for our workings, I would write down 38.057 dot dot dot. You can always write the dot 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 just to show that you are using the answer button, basically, but you cannot write that. Anyway, you do 63 over 4 pi, divide and take away ANS, our answer, and that will be the area of the segment, which is 11.422, so on. We're being asked to round it to 3 significant figures, so that will give us 11.2.